Alrighty, welcome back to another division video with your teacher. Today we need to answer an important question. Yesterday you guys did some amazing dividing where you turned your division sentences into fractions and you simplified them beautifully and used that to solve those problems without having to worry about too many other factors. But today we need to talk about what happens if your division sentence cannot be simplified down in a really helpful way. Maybe it could be simplified a little bit, but it just might not be comfortable, it might be cumbersome, or you might have just decided that, man, that's one strategy, but it's not my favorite strategy and I want to try some different ways. So we're going to talk about using long division to solve division sentences that have two-digit divisors. One of the main strategies we're going to use for this is estimation. I did not mean to do that. Estimation. Perfect. So we're going to use estimation, and we're also going to pair that with using a little bit of multiplication to check our work as we go. When we're estimating in math, that's usually going to mean that we're rounding our numbers. It's important to note that we're often going to be rounding to the nearest 10 or 100 or even 1,000. However, estimating is really there to make things easier. That said, I want you to think about some other numbers that you might actually end up rounding your dividend or divisor to that aren't a 10, 100, or 1,000, but that would be really easy to work with. All right, team members, some other ones that you may end up rounding to are 1, 2, or 5. So think about that. And really, you might end up going towards any of these 1 through 10 numbers because you may know division facts or multiplication facts that are going to help you out. But I can tell you right away, you guys are really good at dividing things by 1. You guys are really good at dividing things by 2. And you're really good at dividing things by 5s. So just know that while we are talking about rounding here, we aren't always 100% of the time going to round to a factor of 10, though usually when we're rounding it will be one of these factors of 10. All right, guys, all of that said, let's jump in and see what this is going to look like. Let me clean off my board here for you guys. Remember, if you're having any questions about this, please reach out to me. You can text, you can call, you can email, you can comment in Google Classroom. Let's use this weird color. I like that. All right, team members, let's just take a look and use estimation to solve this problem. 348 divided by 12. Now, right away, you may be thinking, well, yeah, I could divide that down. I could simplify that and definitely turn this into a one-digit divisor here. But I don't want you to worry about that strategy right now. You could use that strategy to check your work, but I really want to look at what this would look like if we used estimating. So our first step is we want to round our divisor. What could we round this divisor to that would be a number much easier to work with? I'll give you a couple seconds to think about it and write down your idea. Alrighty, if I were you, I would probably round 348 to 350. That's a nice round number. We rounded to the tens place here, and we will be able to divide that. Now we want to round our divisor here. What can we round this divisor to that will be easy to work with? 12 rounds to... If you said 10, you are right there with me. This division problem is a much easier problem for us to work with for sure. There's quite a few ways we could solve this. We could do some long division. We could also just take this right away and put it in fraction form and divide each of these numbers by 10 because they both have a 0 at the end. 350 divided by 10, get to cancel those out, would be 35 over 1. Remember, if you have those same digits at the end there, those zeros, you can always cross those out. 35 over 1 just equals 35. So that means that our estimated value here is going to be 35. That is awesome. I'm going to clean this up a little bit. So when we estimated, our answer is about 35. Now that we've estimated, it is time to solve. Let's put us in a different color. Let's do this green. Now we're going to solve. So we know that our answer is going to be about 35. You guys may have noticed I have this funky line up here at the top. So I am going to actually turn that into a little number line with 35 right in the middle because I know my number is going to be about 35. So that means that it could be anywhere near 35. One strategy for you guys, if you're using lined paper, I'd probably turn that paper sideways. That will allow you to make some really easy number line stuff. And it will also help you line up that place value. If you notice, I put one place value per line section there. So just a strategy that you can use to help you out at home. All right, so I've got this little number line going just to help me out here a little bit because I know that my answer is going to be close to 35. Now let's see what happens when we solve this. We're going to set it up just like a regular long division. 348 divided by 12. So right away, we're going to have to be continuing to use that strategy of estimation. We are going to look here and say, well, 12 cannot fit into 3, but it can fit into 34. About how many times can 12 fit into 34? Well, I know it's got to be close to this number 3 here. If I check that, 12 times 3 is going to equal 36. 36 is too big, so that tells me right away I can probably pretty safely go with 2. Let's try that. We'll put a 2 right there. Remember, I didn't put it here because 12 cannot fit into 3. So 2 times 2 is 4. 2 times 1 is 2. Do some subtraction there, and we are going to be left with 10, and then we need to drop down our 8, drop it like it's hot, you guys know. And that means we're now going to have to ask ourselves, how many times does 12 fit into 108? That's a really big question to ask ourselves. Let's go back to that estimate. I see here that we have a 5. That could be one starting place, but let's actually check our number line before we move on. We know that it needs to be a number close to 35. We also know that it's going to have a 2 in the tens place. So right away, you know it can't be any of these because these do not have 2's in the tens place. So I guess maybe my number line should have gone on a little farther this way. Today that didn't happen, but let's see if that works out for us. Which number that has a 2 in the tens place is going to be closest to 35? Think about it in your head. All right, so you're probably thinking, well, gosh, 29 is the closest number in the 20s to 35. So if I were going to guess, I would guess that 9 is probably what I want to start with. But I need to check that before I just go willy-nilly put it in. So I'm going to multiply 12 by 9 and see if it looks like that's going to get me close to 108 without going past 108. So 9 times 2 is 18. 9 times 1 is 9, plus 1 is 10. Ding, 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 we have a winner, team members. We can put that right in here. We know that 9 times 12 is 108 because we just solved it. We subtract and have nothing left over. That's really exciting, guys, because it worked out so nicely. And this is one way that we can use that estimate. Now notice, 35 is pretty close to 29. That's a very good sign. It's only 6 numbers away, which when you're using something in the hundreds, 6 numbers is not very far away. However, this could feel a little tricky because it doesn't actually have any of the same digits. So it's really important. This is one of the reasons I used a number line here. That can be really helpful because it's not actually in the 30s. It doesn't have a 5 in the ones place. And so using this number line really helps me to say, oh, what's the closest number to my estimate that might work? And that really just cleans up a lot of that time you might spend doing guess and check. All right, if you weren't sure about that 9 being the closest one, or you hadn't quite thought it through that way, you could spend 5 or 10 minutes doing all sorts of multiplications, 12 times 5, 12 times 6, 12 times 7, all the way until you finally get there. So that estimate is really a guide to help us move in the right direction so we don't end up wasting any of our time. Very nice. So let's clean some of this up. We've done a wonderful job. We found that when we solved, we equaled 29. So, are we done? I hope you're shaking your head and being like, no, we're not done. What are you talking about? We have a very important step left, and that is to check our work. So we are going to multiply. Now, we've been talking a whole heck of a lot about our vocabulary. We've been talking about labeling these words because it's really important to know which numbers you need to multiply together. So you notice I wrote out this problem here. And when we want to check our work, I'm going to tell you guys we're just going to do it in the opposite direction. Now we want to go this way. So we want to have 29 multiplied by 12 should equal 348. You can even put that in there. Should equal 348. And that is one way to look at it. We're also going to remember that we are multiplying our quotient by our divisor. So let's check that out and see how we did. 29 multiplied by 12. All right, we know we have 2 digits here in our second product, so we're going to have 2 partial products. Just keep that in mind. Think about all those things we need for multiplication. I know it's been a while. 2 times 9 equals 18. We've got to carry that 1. 2 times 2 equals 4 plus 1 equals 5. Very nice. Now, think in your head, what is the next thing I'm going to put on this problem? I hope you're like screaming, placeholder, without bothering your family members, of course. We must put a placeholder. We want to get rid of that. We don't want that anymore. 1 times 9 is 9. 1 times 2 is 2. And now all that's left is adding up these partial products. 8 plus 0 equals 8. 5 plus 5 plus 9 equals 14. Carry the 1. 1 plus 2 is 3. Alrighty, team members. Very exciting. We have done it. Perfect work. I hope that this gave you a clue about how we can use estimation to help us solve these 2-digit multiplication or these 2-digit divisor multiplication problems. They are always going to require a little bit of estimation, a little bit of guessing and checking, and we're always going to have to do a little bit of multiplying throughout the process to see that we're on the right track. I really recommend that once you guys estimate, you make a number line to help you keep track of where you're at with your numbers. That's one really great strategy. All right, guys, I'm going to set you free to do some practice. Remember, reach out if you have